So you've just finished the triangle uh, assignment and perhaps the discussion. I want to take a look at the responses from the discussion and see what this tells us about the trig functions. There's really two goals that I have with that assignment. One is to get you so that you don't have to think about what two sides you need. When you're given a right triangle and an angle in that triangle and you say, give me the sine, you can just grab the two sides. You don't have to think even opposite over hypotenuse. You just know what two sides to grab. That's my first goal. Second goal is to start looking at the basic trig identities because they come right out of this. Every time you notice a pattern that speeds you up and gets you to get through that assignment faster, you've just identified a trig identity. So for instance, I got a triangle here and I'm going to work my way through it. I want the sine of angle D. I know it's that side over that side, D over F, right? Now one of the things that I may have noticed that once I have the sine, I don't really have to think too hard to get the cosecant. It's the reciprocal, just F over D, right? Well, that's an identity. Let's make that official right down here. I'm going to have these things called the reciprocal identities. And the first one I notice is that the cosecant of any angle is equal to the reciprocal of the sine. Right? I also, if the cosecant is the reciprocal of the sine, it is true that the sine is the reciprocal of the cosecant. So really, I think this is two different identities. I'll write the other one down over here. Sine of theta is 1 over the cosecant of theta. Okay? And likewise, once you've got the cosine of d, e over f, then it's easy to get the secant because you just flip it upside down, f over e, right? So the secant of theta is the reciprocal of the cosine, and the cosine is the reciprocal of the secant. Right? Now there's another one in there for tangent. I haven't written down tangent yet, but tangent and cotangent work as well, so let's write it down here. Cotangent theta equals 1 over the tangent theta. And the tangent theta is the reciprocal of the cotan theta. So there's what we call the reciprocal identities. They're just recognizing that you're using the same pair of sides to make the sine or the cosecant. You're just making the fraction in a different order. Now, not as many people catch this next one, but people notice this from time to time, that once you have the sine and cosine, you don't really have to think much to get the tangent because you just grab those two numerators, just d over e. This was opposite over hypotenuse, this was adjacent over hypotenuse, and what I want is opposite over adjacent. So there's the opposite, there's the adjacent. You just grab them. It turns out that this is an identity that we can work with. Not immediately obvious, but let me just point out that this is called a quotient identity now. A quotient identity. And that the tangent of theta is the sine of theta divided by the cosine of theta. Now I know it's not immediately obvious that that's the case, but let me just show what happened here. That if I take the sine of theta in this problem, what was the sine of theta? D over f, right? And I divide by the fraction which is the cosine of theta, e over f. I mean, how do I divide fractions? I have the first one, and I'm going to multiply by the reciprocal of the other one. And the f's cancel out. Multiplying and dividing by the same thing. They cancel out. We end up with just d over e. But d over e was the tangent of that angle. So if I take the sine and then I divide by the cosine, I end up with the tangent. Once you have the tangent, you can take the reciprocal to get the cotangent. Right? And actually, that's another quotient identity that we often will write down, that the tangent of theta is the sine over cosine, but the cotangent of theta is the just the reciprocal. the cosine divided by the sine of the angle. Okay. If you recognize that you could just grab the numerator and the numerators of the sine and the cosine to write down the tangent, then you've discovered that quotient identity. Okay. Now, there's one more set of identities that people definitely notice as they're doing this. And when they go looking at this other angle now, I've got all the trig functions of D. Now I'm going to get all the trig functions of E. So I need the sine of E, which is E over F. And I happen to notice that that's the same as that one, that the sine of E and the cosine of D are the same. Likewise, when I write down the cosine of E, adjacent over hypotenuse, D over F, that's the same as the sine of D, that those two are always equal to each other. The sine of one angle is the cosine of the other. Likewise with the tangents and cotangents, that these two will be equal to each other, and those two, and the secants and cosecants. The thing that's happening is that when we switch our point of view to the other angle, the opposite and adjacent swap roles. So when I'm looking at the tangent of E, I'm looking at the opposite from E to the adjacent E, that's E over D, but from the point of view of angle D, E over D was adjacent over opposite. Okay? It's still the same two sides, but we're just calling them different names because we're looking at them from the other side of the triangle. Okay? So anyway, and you've got the cotangent is, this is D over E, this one is F over D, and this one is F over E. Right? That once you know all the trig functions for one angle, you've got them for the other. Just you got to swap them around. Okay. How am I going to write that as an identity? Let's look at this first one. The sine of one angle is the cosine of the other one. Well, one of the things we noticed earlier is that the two acute angles in a right triangle are complementary angles. They add up to 90 degrees. So if you know one of them, you get the other one by 90 degrees minus that. So if I'm here, these are going to be what I call the cofunction identities. And the first one is that the cosine of an angle is the sine of the complementary angle. It's the sine of 90 degrees minus theta. Likewise, the sine of an angle is the cosine of the complementary angle. In fact, we're starting to see right here where the name cosine comes from. Cosine is shortened from the old version, complementary sine. That is, if you want the cosine of an angle, you want the sine of the complementary angle. The complementary sine is the sine of the complementary angle. Likewise, the cotangent of an angle is the tangent of the complementary angle. The complementary tangent of an angle is the tangent of the complementary angle. It also works like this, that the tangent of the angle is the complementary tangent of the complementary angle. The cotangent of the other angle in the triangle, right? And secant and cosecant as well. So the secant of theta is the cosecant of the complementary angle, and the complementary secant of an angle is the secant of the complementary angle. Right? Theta and 90 minus theta are the two angles in that right triangle. All right. These are three sets of what we call the basic identities: the cofunction identities, the quotient identities, and the reciprocal identities. There's one more set of basic identities that are called the Pythagorean identities, and we will look at those in another video.